DIVICO is an international project supported by the 2020 Horizonte program of the European Committee, implemented by the GIZ in cooperation with 13 organizations with experience in 4 continents. The main goal is to establish a closer cooperation between technology European suppliers and biogas stakeholders in participating countries. The project works through different initiatives like a digital platform, seminar development, technical meetings and visits to plant in different countries. On their website you can access to different documents, dossiers and developed webinars.
Iniciamos hoy en la provincia de Córdoba, centro de la República Argentina, una serie de visitas virtuales del proyecto DIVICO, en los cuales van a poder ver en detalle cada una de 5 plantas de última generación realizadas en nuestro país.
Specifically in the city of Rio Cuarto, in the south of Cordoba province, we visited the structures set up by the bioelectrica company CGY, constituting one of the hubs for companies developing projects for Argentina, where you can appreciate a real integrated complex of digesters for the generation of renewable energy, which uses as a substrate maize oil and light vinasse from the manufacture of bioethanol, among others, through 2 biogas production units and a larger structure from whose process the fuel is obtained. The first plant built is called Bioelectrica 1 and is located 500 meters from the main complex. Currently, after an increase in the number of engines initially available for this purpose, it generates 3.2 MWh of electrical energy, which is uploaded to the national interconnected system. Initially, this unit was fed with maize silage and manure from animal raised in the area, but it timely adapted its scheme to minimize the use of that reserve. Today, it incorporates only 5% of chopped maize, adding used edible oil that comes from the city, fruit and vegetable waste from the local supply market, cattle and pig manure, plus the vinasse that derives from maize processing in the bioethanol plant.
Asimismo, esta planta genera energía térmica que le sirve para calentar sus propios reactores, también para intercambiar energía con la planta de producción de bioethanol. Igual que Bioelectrica 2, esta energía térmica significa un ahorro muy grande para la huella de carbono de la planta de producción de bioetanol. Esta planta, al igual que la central Bioelectrica 2, trabajan los 365 días del año, las 24 horas del día. Genera el biogás, que es combustionado en los motores de combustión interna, que tienen un generador para producir energía eléctrica. Son plantas de alta eficiencia energética. Y bueno, de la cual tanto esta planta como la central Bioelectrica 1 nos sentimos muy orgullosos de poder contribuir a mitigar el calentamiento global y a luchar contra el cambio climático, elementos muy necesarios hoy para el desarrollo sostenible de nuestra sociedad.
The final digestate that comes from the biodigesters has a concentration of 1:1.5% of solids, becoming an excellent biofertilizer for the fields, successfully contributing to the circular economy that the company has as a spirit and management policy. Along with the Rio Cuarto plant, which produces ethanol, Bioelectrica 2 was built, a generation unit that produces biogas to transform it into electricity, using as a substrate the same components as plant number 1, that is, used edible oil, fruit waste and vegetables, cattle and pig manure, 5% chopped maize as stabilizer in the recipe, and light vinasse.
Nuestra planta de procesamiento cuesta como primera medida o como tanque primario, un tanque de recepción de alimentación, de sustratos, donde se ecualizan los sustratos. provenientes de la planta de bioetanol, provenientes de los residuos de aceite de la ciudad de Río Cuarto y algunos otros sustratos que podemos usar siempre dentro del concepto de economía circular. Ese tanque de recepción de vinaza es un tanque de 2.000 metros cúbicos con paredes vitrificadas, con agitación. La idea de ese tanque, como dije antes, es ecualizar, digamos, las materias primas antes del ingreso al reactor primario de producción de biogás.
Once the raw material is equalized, it is pumped to a primary reaction tank with a capacity of 8,000 cubic meters, built with vitrified walls and equipped with an agitation system, where it remains for 30 days, which is the time of residence of this raw material in the reactor for the generation of biogas. This biogas, whose composition is close to 54.55% methane, is housed under a plastic cover of 4,000 cubic meters secondary reactor. In this reactor, the anaerobic digestion process of the substrates is completed for another 20 or 25 days. So finally, that content of organic matter, which initially is 8 to 9%, remains at 1%, having delivered up to there all its energy through the production of biogas.
Este biogás luego es purificado a través de un proceso donde se eliminan algunos componentes como el sulfuro de hidrógeno y alimentado posteriormente, acondicionado, deshumidificado y alimentado a los motores de combustión interna, que en este caso producen dos motores, cada uno de ellos 1,2 megavatios hora para producir en conjunto 2,4 megavatios hora.
This electricity is supplied to the national interconnected system and constitutes a contribution from the group that produces renewable energy as a way to make crystal clear the concepts of circular economy. The outgoing digestate returns to the bioethanol plant to be used as a nutrient to obtain fuel in the fermentation process, thus consolidating a successful integration between bioethanol and biogas production. Bioethanol is produced through alcoholic fermentation by means of yeasts, which transform the simple sugars that come from biomass, giving as a final result ethanol, carbon dioxide, and maize distillers, which is used in animal feed. In the case of maize, the starch contained in the grain is the only component that is transformed into alcohol. For this, specific enzymes are used to hydrolyze starch to simple sugars such as glucose. The product of this action is distilled, with the aim of producing alcohol of adequate quality and concentration. From this process derives a byproduct called light distillate or vinasse, which is one of the key elements in the load of biodigesters. The other co-substrate used comes from waste oil collectors, a social program carried out by Rio Cuarto in the community of Rio Cuarto, as well as waste from the fruit and vegetable markets in this city. 50 liters of recovered oils are supplied daily to BG2. Likewise, the digesters are capable of receiving manure from fattening animals, dairy farms, and pigs. The raw materials are stored in tanks with a capacity of 2,000 cubic meters. Thanks to the integration achieved between all the plants, large storage volumes are not required. Each group of digesters is equipped with its equalization and storage tank, and both are connected by pipes and pumps to the Rio Cuarto bioethanol plant. The daily feeding of the digester consists of a mixture of the different components listed in variable proportions according to availability. Each digester has a central agitator in order to keep the biomass being processed in motion, assisted by a system that allows to vary the speed and frequency of work. The hydraulic retention time, as we have already mentioned, is 30 days at a temperature that varies between 36 and 38 degrees. During this period, different types of bacteria decompose the raw material, releasing methane and carbon dioxide as the main gases. The plants in the complex have a primary and secondary tank, plus a tertiary digester capable of extracting the remaining gas from the substrates. They have stores of different types. Some of these, made of concrete, have a layer of insulation and exterior finish in sheet metal. Another group is made of vitrified sheet metal, mechanically reinforced from below, and also covered for insulation, which allows reducing the demand for heat to maintain the temperature and avoiding oscillations inside the two tanks. The tanks are covered by a special plastic double membrane. The first one is the one that allows to contain the gas. The second forms an upper chamber, which is kept inflated by air pressure, regulated by blower motors that continuously work, added to outlet valves, which work like the inflatable games for children that we know. The pressure of these two chambers allows storage of the generated gas without losing the exterior curvature of the dome. The Bioelectrica 1 complex has a waste storage area, microtanks, micronutrient dosage systems as a 100 cubic meter manure receiving tank, a 2000 cubic meter temporary storage tank for light vinasse, and a storage area for the maize silage. The digesters and post-digesters are all connected, allowing an integral management of the material in fermentation. For its part, the Bioelectrica 2 complex has a 2000 cubic meter vinasse storage tank and an 8500 cubic meter digesters and a 4400 cubic meter post-digester. To get optimal transformation and good biomass production, a certain temperature is required inside the biodigesters, which must be supplied by external heat since the reactions do not generate heat. Here, part of the heat recovered from the generator motors is used to maintain the internal temperature of all the tanks. The selected rank for operation is from 36 to 38 degrees and the heat is applied through external exchangers, where the heat conductor is the water that circulates in them, recovering the energy contained in the exhaust gases. The cooling ducts of the motors are coiled for heating the mass in digestion. The temperature is permanently controlled and the automotion and control systems allow it to be stabilized inside all the tanks, independently of the external ambient temperature. The system is completed by the help coming from the isolation of all the biodigesters to avoid energy losses. All units are integrated into the agro-industrial complex made up of the ethanol and biogas plants, allowing the use of surplus heat in the first one, reducing costs and emission produced by the use of fossil natural gas in the boilers. The biogas requires a series of treatment before being used by engines. In the particular case of that produced by vinasse, it has a large amount of hydrogen sulfide that must be eliminated. Within the biodigesters, minimum proportion of air are injected to ensure that specific bacteria are part of the desulfurization process. This is placed in the internal networks that can be removed and cleaned when the digester is open during maintenance periods. This procedure is complemented with specific external filters through which the biogas passes and is purified. When leaving the filters, the gas is cooled by chillers to remove the moisture content through the condensation of water vapor that is collected and extracted. Then it is filtered and the pressure is adjusted to finally feed the generator motors. The average gas composition is 56% methane, which gives the gas its calorific value. The entire system is equipped with a special room where the different pipes that carry the material come together. Pneumatic actuator valves and electric motors allow total control of the biomass loading, unloading, circulation, and heating movements. The biodigesters are remotely monitored and operated in a general control room that receives all the information. From this room, different actuators, pumps, motors, and mechanisms can be operated in order to achieve optimal feeding, maintaining temperature, as well all the parameters that make for optimal operation. The collected data is transmitted online, also allowing an external remote supervision of the operation of the plant. There are sensors that record the filling of the digesters and post-digesters, the operating temperatures, the valve positions, and the status of the motors. The plants have internal combustion engines specially adapted for continuous operation with biogas. In Bioelectrica 1, there are 4 with their corresponding generators, which together have a maximum supply capacity of 4.6 megabytes. Instead, Bioelectrica 2 features a single generator engine. This equipment is located inside specially conditioned and insulated containers to reduce noise generation, as well as strong temperature fluctuations. Each motor has its own continuous maintenance plan in order to guarantee optimal operation, avoiding breakage and failures that would imply the interruption of electricity generation. In case the gas cannot be used due to engine operation output, there are safety torches that are lit to avoid throwing unburned methane into the atmosphere. The system has backup generators and boilers to maintain the temperature and operation of the critical electric motors that must continue functioning. The digestate has the possibility of being derived to different sites of the complex since it is applied for different uses. 70% goes to the fertilizing irrigation of fields. These are analyzed by external laboratories in order to determine the content of their main nutrients. The company has a complete follow-up and monitoring plan for the batches treated with it. Soil sampling is carried out annually and the variation in yield obtained in the different crops that occur in the rotation are recorded. The liquid material, which is stored in a lagoon, is extracted by special pumps. A specific sector was built in the Bioelectrica 1 complex for container loading and digestate distributors. In these plants in particular, there is 30% of digestate that is conducted and used in the maize starch transformation process as a circular current. Generation plants have their own transformer sector in order to raise voltage and minimize transmission losses. A transformer is used for each engine. They are built very close to an electrical transformation and distribution node. All electricity management is remotely monitored by the commercial and distribution company CAMMESA, based on the delivery reports, operation exits and more the company builds. The biodigesters have been built by a company specialized in concrete called Arinco. The electromechanical part of control is also national. The vitrified sheet metal biodigesters are imported and have been assembled by national companies. These special pumps, grinders, motors and generators are imported.